Hello, ladies and gentlemen. Welcome back to my space. It's Matefaro here as usual, and this is the first of possibly many videos in a new series that we call the integration series. Integration is a very wild aspect of calculus, and as such, we can never exhaust possible aspects of integration. So I intend to drop different videos concerning different aspects of integration so that we can continue to learn together. In this first volume, we are looking at logarithms and integration. It could be very tricky, but it is also fun. So without wasting much of our time, let's get right into it with these three questions. So before we go deep into the questions, so the first thing I would like to do is to have a refresher of the properties of logarithms, because they are going to be very useful for us as we forge ahead in this particular volume. So properties of logarithms. So first and foremost, we know that the most common type of logarithm we use in calculus is the natural logarithm. So definitely this is what we're going to be using the more in this series. But we should remind ourselves that natural logarithm of x is simply the logarithm of x to the base of e. So when we see ln, it comes from the French word logarithm natural. So it just means natural logarithm. And anything we say about the properties of natural log of x, just remember that it is about logarithm of x to base e, and it is going to work with any base. So the basic properties, the first one about the definition of logarithm is that if we say that logarithm of x to base b is equal to n, then it implies that b to the power of n is just equal to x. That is the defining property of logarithm. So I'm not going to say too much about that. So b to the power of x is equal to b to the power of n is equal to x. Then the second property which I'd like to talk about is the fact that it boils down from the first defining property. So we have that log b base b is equal to 1, since b to the power of 1 is b. And as such, when we write logarithm of 10, so the common logarithm, which is always to base 10, is going to be 1, and natural log of e is also going to be equal to 1. Then we also have the other property, logarithm of x to the power of b to any base. Okay, let me use p as a power, then base b is equal to p times logarithm of x base b. In other words, if I have natural log of x to the power of n is also equals to n times natural log of x. All right, then these are very basic properties, I must confess. So if I have logarithm of a to base b, it is the same thing. This is what we call the change of base, logarithm of a to any random base over logarithm of b to that same base. And as such, it means that we can write logarithm of a base b as natural log of a over natural log of b. And if k was equal to a in this case, we would see that logarithm of a base b is the same thing as 1 over logarithm of b base a. Then some common ones about sum and product. Natural log of a, or logarithm of a times b, is equal to logarithm of a plus logarithm of b. And we also have that logarithm of a divided by b is equal to logarithm of a minus logarithm of b. So you should be careful. This is just, maybe I shouldn't have named it, but you should be careful that natural logarithm of a times natural logarithm of b is not equal to natural logarithm of a plus b. Similarly, natural log of a over natural log of b is not equal to natural log of a minus b. So these are common mistakes people make. Then the next one I would like to talk about is the one that is not popularly talked about. Is the fact that if I have a base to the power of logarithm of anything n to that same base, it is equal to n. So this stems from the fact that exponential and logarithms are, and exponential functions and logarithm functions are inverses of each other, and we know that inverses cancel out each other. So if f and g are inverses of each other, then f of g of n is just equal to n, and that is the same thing that is playing out here. As a matter of fact, if we do e to the power of natural log of x, it is just equal to x. That is the same thing we are talking about. You remember, natural log of x is logarithm of x to base e. So, and along that line, we also have that if we have a or b logarithm of a base any other base, okay, so let me say c, it is equal to a to the power of logarithm of b to that same base. Okay, this stems from the fact that if you look at property 8, we can see that the same way we were able to write n to be b to the power of log n base b, I can rewrite b as well as something else. So I can write b as x to the power of log b base x. So if I replace this b with this b that is equal to this, then this is equal to x to the power of log b base x, that is our b, then to the power of log n base b, and that is equal to x to the power of log b base x log n base b, and this is equal to n. And because multiplication is commutative, we can actually change the red and the black power, switch them to become x to the power of log n base b times log b base x. This is also still equal to n. Okay, so if we are careful about this and we see it very well, we also see that if we change c to e here, that gives us the following corollary, that b to the power of natural log of a is equal to a to the power of natural log of b. So what I have done here is something that we're going to need with one of the questions that we have above there. So there could be many other properties, but these are these are the properties that we cannot do without. Okay, maybe there is another one here that instead of bringing down the p, if the power were to be on our base, so b to the power of p is the base, then if the p comes out, it comes out as a reciprocal, so 1 over p log x base b. So that is another one that we can watch out for. So with that, we can move on to the next question. So the first question here says we should find both the derivative and the antiderivative of natural log of x. Maybe I should also include logarithm of x, that is to base 10. So I'm not going to gloss over the derivative since it is something that is very common. It's a standard derivative that if y, so the derivative with respect to x of natural log of x is just equal to 1 over x. We could prove that using the limit definition of natural logarithm, but that is not what this video is about. This video is mainly about integration. Then generally, the differentiation of the natural log of a function is always equal to the derivative of the function over the function itself, and that is what works out with natural log of x. The derivative of x is 1 over x itself. That being said, if it were to be logarithm of x, the derivative of logarithm of x to any other base, so let's say base b, how do we do this? First and foremost, we change this to logarithm of x to base e over logarithm of b to base e. In other words, this is the same thing as the derivative of natural log of x over natural log of b. But natural log of b is just a constant, so I can pull it out. So that will be 1 over natural log of b times the derivative of natural log of x. And we know that the derivative of natural log of x is 1 over x. So this is 1 over x times natural log of b. So if the b is 10, which is the common log, the answer will just be 1 over x ln 10. For the integral, that is where the fun begins. So welcome to the fun part of this video. So we want to find the integral of natural log of x dx. To take the integral of this, the only thing we can use here is to use integration by parts. That is at least the method I know of, integration by parts. And you recall that the integral of u dv is equal to uv minus integral of v du. For cases like this and cases like sine inverse of x, tan inverse of x, and so on and so forth, we use the integration by parts where, so let me call this I, where we set u to be natural log of x since we know its derivative. Mostly when you are using IBP, apart from the acronym ILATE that tells you the hierarchy, intuitively what should be your u is the thing that is easily differentiated. So u is natural log of x here, and dv is dx. We need du and v. So du is the derivative of natural log of x, that is 1 over x dx, and v is the integral of dv, which is integral of dx, which is equal to x. Therefore, using IBP, the integral of natural log of x is equal to uv, that is x times natural log of x, when we multiply these two, minus integral of v du x times 1 over x dx. And that is going to be equal to x natural log of x minus integral of 1 dx. But what is the integral of 1? That is just x. So this is equal to x natural log of x minus x plus c. Beautiful. So we've seen that, so in general, or in conclusion, the derivative of natural log of x is 1 over x, while the integral of natural log of x with respect to x is x natural log of x minus x plus c. The next thing on our list is to take, here's the second question, is to evaluate this ugly looking question. It looks ugly, but as a matter of fact, it is a very simple expression. So we are told to integrate 7 to the power of log 5 base x minus 5 to the power of log 7 base x. If I wanted to make it even interesting, I could say plus let's say 3 to the power of log 3, log x base 3 dx. Now it becomes even more interesting. So when you look at the first two terms, looking at our property here, property 9, we have seen that b to the power of log a base c is the same thing as a to the power of log b base c. So such that a and b can switch places. So that means that the first summand and the second summand are actually the same thing. The first integrand and the second integrand. So it means I can write this as 7 to the power of log 5 base x minus 7 to the power of log 5 base x. But again, we've seen that this is just equal to x dx. Then this cancels this, so we're just left with integral of x dx, and that is nothing but x squared over 2 plus c. Beautiful. And finally, the last but definitely not the least, to take the integral of this one. This one looks even much more uglier, but let's see how fun it is. So this question, to find the solution to integrate this, I think what comes to me first is to use u substitution. So let u be equal to x over e to the power of x. Once I saw this question, I fell in love because it has a lot of parts that makes it even beautiful. So how do we do u substitution? After getting u, the next thing is to take the derivative. So how do we find the derivative of this? So anytime we have a function that has the exponent to be a function of x, the usual trick is to take logarithm of both sides. So to find the y dx here, we take logarithm of both sides. Of course, the natural logarithm. And what does this give us? So we have natural log of u equals to natural log of x over e to the power of x. And why do we use this trick? it is for us to be able to bring down that x using one of the properties we saw here. So property 3. So the p can come down. We can use that same property here. So this is equal to x times the logarithm of x over e. And another property, when we have logarithm of a over b, we know that is logarithm of x minus logarithm of e. In other words, it means natural log of u is equal to x times natural log of x. This is exactly the reason why we had to spend some minutes going over the properties of logarithms. So natural log of e is 1. And it means natural log of u is equals to x natural log of x minus x. So we need to differentiate both sides now. So if we differentiate the left hand side, we get 1 over u du dx, that is using chain rule. And on the right hand side, we could decide to use product rule on this and then take this. But of course, this is looking familiar. We've seen that the integration of natural log of x is x ln x minus x. And since integration is actually antiderivative, we know that the derivative of x ln x minus x is just going to be natural log of x. That's the beauty. That's exactly why I chose that question first. Then it means du dx is equal to u times natural log of x. But again, what was our u? Our u was x over e to the power of x. So this is x over e to the power of x times natural log of x. Beautiful. What does that mean? It means that we can now rewrite our expression, or we can say the x is equal to the u over this expression, so which is x over e to the power of x times natural log of x. Now we can write the integral. So the integral of natural log of x times x over e to the power of x plus e over x to the power of x dx is equal to the integral of natural log of x. So we said our u is x over e to the, then so it means this is going to be u plus, and this other one, e over x, is just the reciprocal of x over e. So this is 1 over u times, and this is what we got as dx. Dx is du over, so when you look at that carefully, x over e to the power of x here is our u, right? Isn't that our u? That is our u. So this is u times natural log of x. And this is where it becomes interesting. All traces of x goes away. So we are left with this is equal to the integral of 1, because when you multiply, when you divide through by u, you get u over u 1 plus 1 over u squared du. But what is the integral of u? The integral of 1, rather, the integral of 1 is u, and the integral of 1 over u squared is negative 1 over u plus c. So finally, the integral, let me just copy paste, is equal to And we bring back the x, back substitute. U is x over e to the power of x minus the reciprocal e over x to the power of x plus c. What a beautiful question. And with that, we come to the end of this volume 1. So we found the solutions to the 3 questions we have here. So the first one, the derivative d dx of that is 1 over x, and the integral is x ln x minus x. The second one, the integral of this is just 0 plus c, and the integral of this is just the guys in the brackets. So we're going to end this video now. So if you have any questions or observations for corrections, do well to comment below in the comment section. Like, share, and subscribe to our channel. Thank you. See you in the next video. Bye.